Protecting steel structures in the oil and gas industry from corrosion. Developing new galvanic protective coatings to limit impact upon project coating schedule. Oil and gas asset owners are increasingly looking for longer performance from their corrosion protection, but also want to reduce their overall capital expenditure budget in all areas. Protective coating offers a viable solution to many corrosion challenges found in oil and gas industries, and currently millions of liters of paints are used to protect these assets globally each year. However, the protective coating industry has been faced with many challenges in recent years and has had to wrestle with how to reduce impact on project schedule brought about by late-stage painting activities, how to minimize delays due to painting rework and in-service failures, how to maximize the cost effectiveness of time spent on painting activities. Galvanic coating contain metal particles that are non-noble relative to ferrous substrate. These coatings form a physical barrier and act as a sacrificial anode when the barrier is damaged. Zinc contain coatings may be considered galvanic. New galvanic coating based on organic zinc epoxy resins can significantly improve painting productivity during project constructions. Galvanic coating often represent part of a larger painting scope on oil and gas capital projects. Therefore, savings made here can offer significant benefit in terms of improved productivity and subsequently lower painting cost. Historically, zinc containing paints or protective coating have been divided into two types: inorganic zinc coating based on ethyl silicate, organic zinc coating based on epoxy resins. In both types, the zinc is present in the form of zinc dust particles. This amount of zinc present plays a key role in determining the degree of corrosion protection provided. The more zinc dust that is present in the final coating film generally leads to reduced corrosion creep when tested in stimulated corrosion inducing environment. The level of zinc present is prescribed in a number of standards such as ISO 12944-5 2018 and the Steel Structures Painting Council document SP20. The two type of coating also differs in their intended use. Inorganic coating can be used to provide corrosion protection across a wide range of temperature, typically up to 400 degrees Celsius, due to their silicate backbone. Epoxy zinc coatings are limited to providing corrosion protection across more limited temperature ranges, usually no more than 120 degrees Celsius, due to their organic backbone. On the face of it, inorganic zinc based paints offers a better option and have a historical been found to offer best level of corrosion protection of the two coatings categories when comparing products with like zinc contents. However, inorganic zinc coating have some significant drawbacks when used to steel protection. 1. The ideal application condition for the solvent-borne inorganic zinc galvanic coatings are 20 to 25 degrees Celsius with a relative humidity between 50 to 90%. Painting in condition outside of these can significantly increase drying time and reduce productivity. 2. Solvent-borne inorganic zinc silicate have a tendency to mud crack when applied too thickly, leading to rework cost. Minor mud cracking that is tightly adhered may not necessarily be detrimental. However, visible mud cracking may be cause for concern. In addition, it may further increase drying times due to thicker film. 3. The porous nature of zinc is a inorganic zinc silicate binder may cause a gassing or pinholing of subsequent coats. Techniques is to minimize these involves using missed codes, which may lead to longer application times. Failure to address the issues proactively, however, may lead to subsequent repainting activity and incurred cost.